Hi everybody, Jacob Reed here from ReviewEcon.com. Today we're going to be looking at all of the math that you need to know on your AP Microeconomics exam. If after watching this video you still don't feel quite prepared for your AP Microeconomics exam, head down to the link below and pick up the Total Review booklet. It has lots of questions with answers and explanations, along with cheat sheets and exclusive online games to help you get ready for your AP Microeconomics exam. Now let's go ahead and get into that microeconomics math. First, let's talk about the most repeating concept in this class. Decisions are made at the margin, and that means you need to know what marginal means. Marginal is the change in the total. Whether it's marginal benefit, that's the change in the total benefit. Marginal product is the change in the total product. Marginal cost is the change in total cost. Marginal revenue, of course, is a change in total revenue, and the marginal resource cost is the change in the total resource cost. Just remember that marginal is the change in the total. Here's a quick example. We have the total benefit going from 30 units to 35 units. What's the marginal benefit? Well, it's that change in the total benefit for one more unit. That is a marginal benefit of 5. In Unit 1, the first math we have is about opportunity cost. Opportunity cost is the value of the next best alternative not chosen. When it comes to calculating opportunity cost, we have two types of costs you need to be aware of. Explicit cost, that's money out of your pocket, and implicit cost, that's money not going into your pocket, essentially. The two of those things together are your opportunity cost. So for example, if you go to the movies and spend $20 on your ticket along with some popcorn, and you miss out on going to work, which you could have earned $80 by working that day, the two together add up to give you $100 worth of total opportunity cost. It's that $100, not the $20, that is the true cost of going to the movies. That's your opportunity cost because it's the cost of the choice. If you see a production possibilities curve on your test, you could be asked to calculate the opportunity cost of increasing production of one of the goods. If you take the new number minus the old number, that will give you the benefit or the cost of the change in production. So for example, if we go from point A to point B, we have a benefit of 45 units of consumer goods because the old amount was 105 units and the new amount is 60 units. That gives us 45 units of consumer goods as the benefit. Our capital goods are now at 80 units of output, but they were at 170 units of output. That means that the opportunity cost of increasing consumption of consumer goods from point A to point B is actually 90 units of capital goods. The most difficult math in Unit 1 is comparative advantage. That's the ability to produce something at a lower opportunity cost. That explains why most of our lobster comes from Maine, while our corn comes from Iowa. Has to do with lower opportunity costs. Let's look at an example. There are two types of problems you could get when it comes to calculating opportunity costs for comparative advantage. One is an output problem and the other is an input problem. Let's look at output first. The formula for outputs is the other over formula. That means the opportunity cost of A is the numbers you have for the other one, B, divided by A. There are two ways you can see an output question on the AP Economics exam. The first is two production possibilities curves. There'll be straight line production possibilities curves, and when you see these, you know immediately that is an output question. You could also see this as a table, something like this. This shows you the different levels of output both Jason and Henry could produce with their fixed resources. Let's work out this example. So the opportunity cost of A is the numbers for B divided by the numbers for A. That means Jason's opportunity cost for 1 ton of strawberries will be the numbers he has for zucchinis, 4, divided by the numbers he has for strawberries, 8. That reduces down to 1/2 a ton of zucchini for every ton of strawberries Jason produces. For Henry, the opportunity cost of 1 ton of strawberries is 3/5 of a ton of zucchini. And since Jason has the lower opportunity cost in the production of strawberries, that means Jason has the comparative advantage. If we calculated the opportunity cost for producing a zucchini, Henry would have the lower opportunity cost for that. The other type of question you could see with comparative advantage is an input question. When it's inputs, you will see a table, and the numbers in the table will indicate units of labor or land or capital that go into the production of some other good. In this case, we have hours. That's units of labor that go into the production of producing a brake job or painting a car. The formula for calculating opportunity costs when you have inputs is the it over formula. That means the opportunity cost of A is it, the numbers for A, divided by the numbers for B. Let's try that math out by calculating the opportunity cost of painted cars for Amy and Eric. For Amy, the opportunity cost of one painted car is the hours she has for painted cars, 6, divided by the hours it takes to do a brake job, 1. That reduces down to 6 paint jobs for every painted car Amy produces. Now for Eric, the opportunity cost of one painted car is the hours for producing a painted car, 8, divided by the 2 hours it would take to produce a paint job. That means his opportunity cost of one painted car is 4 brake jobs. And here, Eric has the comparative advantage in the production of painted cars. The next bit of math you need to remember for Unit 1 is utility maximizing combinations. The best place to be when it comes to consuming different types of goods is having the marginal utility of one good divided by the price of that good equaling the marginal utility of the other goods divided by the price of those other goods. Marginal utility, don't forget, is the marginal benefit a consumer gets when consuming a good. Divide that by the price to get your marginal utils per dollar. And if the marginal utils per dollar for all goods are equal, you are utility maximizing and you should not change your consumption. If one of the goods has a higher marginal utility per dollar, you should have more of that good. If you have a low marginal utility per dollar for a good, you should have less of that good because you are getting fewer units of happiness for every dollar spent. So for example, let's say I got 30 units of happiness for the last lobster that I consumed. The last ear of corn I consumed, I got 5 units of happiness. Lobster costs $20 per unit and corn costs $2 per unit. Let's take that marginal utility and divide it by the price to give us 1.5 marginal utils per dollar for lobster and 2.5 marginal utils per dollar for corn. Which one do I want more of? Well, I'm going to want less lobster and more corn. Changing my consumption in that way would actually increase my total utility and make me better off as a consumer. In Unit 2, the first math you need to know is the price elasticity of demand. As we know, when prices fall, people demand higher quantities. And when prices rise, people demand fewer quantities. The question is, how much more and how much less? That's elasticity. The first math to find out the price elasticity of demand is the total revenue test. Total revenue is price times quantity. If price falls and total revenue falls, or they both go up, they're going in the same direction, and this is an inelastic price elasticity of demand. If the price and total revenue are going in opposite directions, say price falls and total revenue increases, that's elastic demand. If price falls or rises and total revenue doesn't change, that is a unit elastic price elasticity of demand. Let's try it out with this example. Here we have 2 prices and 2 quantities demanded. If we multiply the price times the quantity at $25, that gives us $250 worth of total revenue. Then when the price falls down to $20, we will multiply that by the 15 units that are demanded at that price. That gives us $300 worth of total revenue. So when the price fell, the total revenue increased. And if you go the opposite direction with the price increasing, total revenue will fall. Since they're going in the opposite direction, this is an elastic demand curve. Unfortunately, there are other types of elasticity that the total revenue test doesn't work with. It only applies to the price elasticity of demand. And so you have to know how to calculate elasticity coefficients. In order to calculate the price elasticity of demand coefficient, you're going to take the percentage change of quantity and divide it by the percentage change of price. That will give you a negative number, but you'll drop that negative to come up with the absolute value of the coefficient. If the absolute value of the price elasticity coefficient is less than 1, that means it's a decimal, then it is an inelastic demand curve. If the absolute value is greater than 1, it is an elastic demand curve. And if it is exactly 1, it is a unit elastic demand curve. Let's try an example. If a 20% increase in price causes a 10% decrease in quantity, what's the coefficient? Well, we're going to take the negative 10% change in quantity and divide it by the positive 20% change in price. That gives us a negative 0.5 elasticity coefficient. That means this is an inelastic demand. Now on that example, the percentage change was calculated for you, but you could get questions where there are numbers and they don't tell you the percentage change outright. How do you calculate the percentage change? So you're going to take the new minus the old, divided by the old, and then times it by 100. That's the preferred method for calculating percentage change on the AP Microeconomics exam. There is another method, and that's called the midpoint refinement method. That's where you calculate the percentage change based on the average in the middle. That midpoint method will get you the right answer on most microeconomics exams, but the math is a little more difficult. That's why the preferred method of the AP Microeconomics exam is the endpoint method that I just showed you. New minus old divided by old times 100. You just have to pay attention to the direction of the numbers here. So here's an example. Let's say the quantity decreases from 200 down to 150. Follow that direction. The new number is 150 and the old number is 200. So we're going to plug that into our formula, and that equals negative 25%, which means we had a 25% decrease in quantity. Now remember, you're going to have to do this calculation twice, once with quantity and once with price. And then you can calculate the coefficient by taking the percentage change in quantity and dividing it by the percentage change in price. The next type of elasticity you need to know is the price elasticity of supply, and the total revenue test doesn't work on supply curves. Make sure you remember that. The formula here is the percentage change in quantity divided by the percentage change in price. That's right, it's exactly the same as the price elasticity of demand. And also, just like price elasticity of demand, an absolute value of less than 1 is an inelastic supply curve, absolute value greater than 1 is elastic, and an absolute value equal to 1 is unit elastic. Let's try an example. Let's say there's a 15% increase in price, and that causes a 30% increase in quantity. What's the coefficient? So you're going to take the 30% change in quantity, quantity is always on top, don't forget, and divide that by the 15% change in price. That gives us an elasticity coefficient of 2. This supply curve is elastic. The next type of elasticity is income elasticity. That formula is the percentage change in quantity divided by the percentage change of income. And while you take the absolute value to determine if this is elastic, inelastic, or unit elastic, that positive or negative tells us something about these goods. Normal goods are going to have a positive coefficient because there's a direct relationship between income and the quantity people buy. When it comes to inferior goods, an increase in income causes a decrease in the quantity consumed, and those are things like single-ply toilet paper or condensed soup. Here's an example for us to try out. Let's say a 5% increase in income causes a 15% decrease in quantity. Can you calculate the coefficient? Plug those numbers in and we have a negative 15% change in quantity divided by a 5% change in income. Now do the math to find out if this is a normal or inferior good. Since the coefficient is negative 3, that negative tells us these are inferior goods. That means an increase in income caused a decrease in the quantity demanded. The next type of elasticity is cross-price elasticity. That's in regards to complements and substitutes. We're talking about the price of one good impacting the demand for the other. The formula for cross-price elasticity coefficients is the percentage change in the quantity of good X divided by the percentage change in the quantity of good Y. If we have a positive cross-price elasticity coefficient, that means these goods are substitutes. That's because the price of one good will directly relate to the demand for the other good. An increase in the price of one increases the demand for the other, and vice versa. If we have a negative coefficient, that means these two goods are complements. That means the price of one increasing will decrease the demand for the other, and vice versa. There's an inverse relationship here. Here are some numbers for us to try out as an example. Let's say there's a 40% decrease in the price of good Y, and that causes a 10% decrease in the quantity of good X. What's our coefficient here, and are these substitutes or complements? When you plug in those numbers and do the math, we have a negative 10% change in the quantity of good X divided by the negative 40% change in the price of good Y. And that gives us a 0.25 cross-price elasticity coefficient here. Since this is a positive number, we know these are substitutes, like Coke and Pepsi. Next up, we have consumer surplus. Consumer surplus is the difference between the marginal benefit or marginal utility of consuming a good and the price of that good. You sum it up for each unit consumed, and that is the consumer surplus within a market or for an individual. Well, I like burritos, and burritos are $5 each. And here we have a table showing my marginal benefit for each of 3 burritos. If I consume 3 burritos this week, what is my consumer surplus? To calculate that consumer surplus, I'm going to take the marginal benefit of each unit and subtract the price. Sum it all up together, and there's my math, and that's $20 worth of consumer surplus. It's the benefit of all of those units minus the price of all those units. Here's what consumer surplus looks like in a market when we're at equilibrium. Right now our equilibrium price is $24 and this market is selling 10 units of output. Calculate the area of that triangle and it will tell us the consumer surplus in this market. Plug in the numbers and we've got $90 worth of consumer surplus here on this graph. Producer surplus, on the other hand, is the marginal cost of production for each unit minus the price. Again, you're going to sum it up for each unit. Let's see what it looks like on the graph. And here we see that the producer surplus is the difference between the current price all the way down to the supply curve because the supply curve is the marginal cost. Calculate the area of that triangle there, and that will give you the amount of producer surplus in this market. Plug in those numbers and we have $100 worth of producer surplus here. Economic surplus within a market is the consumer surplus and producer surplus added together. Find that large triangle's area here, and that will give us our economic surplus. Plug in the numbers, it's $190 worth. A little side note, if there are taxes on a particular good, that tax revenue will also be part of the economic surplus. When economic surplus is maximized, that is allocatively efficient. And when it's not, we have some efficiency loss or deadweight loss. In order to find efficiency loss within a market, let's look at this graph for an example. We are underproducing this good and we only have 4 units of output for whatever reason. Our producer surplus is there in the orange, the consumer surplus is there in the purple, and to find the triangle of deadweight loss, go to the quantity we're currently producing, 4, head up till you hit that marginal cost curve, that's the supply curve at the quantity we're producing. Then keep going until you hit that marginal benefit curve, that's the demand curve. And then your third point for the triangle of deadweight loss is the marginal benefit equals marginal cost point. That's equilibrium, that point in the middle there where the two curves intersect. And that triangle in red, that is our deadweight loss for underproducing this product. Calculate the area of that triangle there, base times height divided by 2, plug in the numbers, and that gives us $54 worth of deadweight loss as a result of underproducing this product. Let's take a look at calculating tax revenue next. If we put a per unit tax on a good, that is going to give us an upward shift of the supply curve. The new supply curve is the supply curve plus the tax. We have consumer surplus in that pink triangle up above. Below, we have the producer surplus in the blue, the deadweight loss there in the red triangle, and we have a yellow box of tax revenue. Multiply the price of that tax, it's the $25 that consumers are paying minus the $14 that producers are receiving after they've paid the government the tax, and multiply that by the quantity of units here, 10. Base times height for that box, and that gives us $110 worth of tax revenue on this product. The first math you need to know for Unit 3 is the production function. And with that, you need to know how to calculate marginal product. That's the change in the total product or the number of things being produced divided by the change in the number of workers. Since the change in the number of workers is almost always going to be 1, you generally aren't going to need to divide by a quantity at all. Let's take a look at these numbers on this chart. See if you can calculate the marginal product of each of these workers. Well, for that first worker, we've got a marginal product of 15. Because we go from 0 total product up to 15 total product. That's a change of 15. Then we go up to 20 marginal product because we have a change in 20 units. Then our next two are 12 and 10. If you got that right, you're on the right track. The marginal cost of labor is the wage that a worker is paid divided by their marginal product. Here we got those same numbers on the table, and let's see if we can figure out the marginal cost if the wage is $60. Plug in those numbers and do the math. At 1 worker, you're going to have $4 marginal cost. At 2 workers, $3. At 3 workers, $5. And at 4 workers, we've got $6 in marginal cost for labor. To figure out the rest of our cost curves, you need to know the difference between fixed cost, that's costs that don't change with output, like capital equipment and land, and variable costs. Those are the costs that do change with the quantity of output, like your number of workers or the amount of electricity you're going to consume within your factory. Add those two together and you get your total cost. That's fixed cost plus variable cost. Here we have another table to practice. Let's see if we can figure out our fixed cost of production here. That is the cost of producing 0 units of output. Can you figure it out? That's right, since the total cost of producing 0 units of output is $10, that means our fixed cost is $10. And not just for 0 units, but for 1 through 6 as well. And that's because fixed costs are the same whether you're producing 0 units of output or 100,000 units of output. Now, marginal cost is the change in total cost. You see a few new numbers there. See if you can figure out that marginal cost for the first unit produced. That's right, it's $8. Show you a few more numbers and see if you can figure out the variable cost for the next unit. The variable cost is the sum of all marginal costs. That's right, the variable cost so far, we're at $14. Now let's put it all together and see if you can figure out all of these missing numbers. There you go. How'd you do? Now we're going to move on to calculating our average costs. Average total cost is the total cost divided by the quantity produced. Average variable cost is the total variable cost, again, divided by the quantity produced. And of course, the average fixed cost is the total fixed cost divided by the quantity produced. And that's because the average of anything is the total of that thing divided by the quantity. Let's try it out with some numbers on the table. See if you can calculate the average fixed cost, average variable cost, and average total cost for 2 units of output here. There's your numbers. Now let's work backwards and see if we can find our total costs from the averages. Remember that the total of anything is the average of that thing times the quantity. There's your numbers. Let's see if we can get 3 more. Remember, the average variable cost plus the average fixed cost will equal the average total cost. And there you have it. Those are your final answers. How you doing? Now finding those same total costs on a graph and calculating them out, you can take the average times the quantity to always get the total. Let's say we have 10 units of output here and our variable cost here is $20. What's our total variable cost? Multiply them together and that's $200. At 10 units of output, our average total cost is $30. Multiply that by the quantity and we have our total cost being $300 at 10 units of output. If we were trying to find our fixed cost, remember that the average fixed cost is the gap between the average total cost and the average variable cost. Here we have that being a value of $10. Times that by the quantity of 10, and that tells us our fixed costs for this firm are $100. One of the most important things you need to know in microeconomics is that profit maximizing firms will produce the quantity where marginal revenue equals marginal cost. Here we have a table with different quantities and different amounts of marginal cost for each unit produced. Well, this firm should keep on producing as long as this marginal revenue of $19 is greater than or equal to the marginal cost of that unit of output. At 3 units of output, the marginal cost of $10 is much less than the $19 worth of marginal revenue. This firm will increase profit by $9 if it produces that unit. So it should. At 4 units of output, our marginal cost is $16, and that is still less than our $19 worth of marginal revenue. And that means this firm increases profit by $3 when it produces that unit. Well, as you can see on this table, marginal cost never equals marginal revenue. So how many should we produce? Well, that 5th unit, we have a marginal cost of $20, and the marginal revenue is less than that. This firm would lose $1 by producing that unit of output. So that means for this firm, 4 units of output is the profit maximizing quantity, and that's because at 4 units, $16 is less than $19, but at 5 units, $20 is greater than $19. There are 2 types of profit you need to know on the AP Microeconomics exam. The first one is accounting profit. Accounting profit is the total revenue minus the explicit costs of production. If a firm has $50,000 worth of total revenue and $30,000 worth of explicit costs, what is their accounting profit? That's right, their accounting profit is $20,000. Economic profit, on the other hand, is your total revenue minus your explicit costs, but then we also subtract our implicit costs. That's the cost associated with being an entrepreneur. Let's say this business owner has an opportunity cost worth $10,000 for being in business. What's their economic profit now? Economic profit here is just $10,000. What that tells us is that accounting profit is always going to be greater than economic profit because we subtract the implicit costs when calculating economic profit. To find economic profit on a graph, first you have to find the profit maximizing quantity where marginal revenue equals marginal cost, 15 on this graph. The economic profit is found between the average total cost for the quantity produced and the average revenue for the quantity produced. Here we have a per unit profit of $4. Multiply that by the quantity or calculate the area of that box, and we've got $60 worth of economic profit for this firm. If you find the average total cost greater than the price at the profit maximizing quantity, that firm will be earning economic losses. That will be the difference between the average total cost and the average revenue at that profit maximizing quantity. For this firm, it's $5 per unit produced. Multiply that by the quantity produced of 10, and that will be $50 worth of economic loss. Now in Unit 4, there isn't a whole lot of new math. Most of the math has been covered in previous units. But one of the new things is the difference between the marginal revenue and the demand. Since single price monopolies reduce the price on all units produced, as they produce more, that will cause there to be a difference between the marginal revenue and the demand. Let's see if we can calculate the total revenue at 2 units and the marginal revenue at 3, knowing that the total revenue is price times quantity, and marginal revenue is the change in total revenue divided by the change in quantity. Well, at 2 units, we have a total revenue of $18, and at 3 units, we have a marginal revenue of $6. If you graph this out, the quantity and the price are the demand curve. The quantity and the marginal revenue are that marginal revenue curve. And because the price decreases as more units are produced, that means the marginal revenue is going to be less than the demand for a single price monopoly. When we put it on the graph, it's going to look like this. And since we already learned the total revenue test for determining the price elasticity of demand, we know that as the price falls when we produce more output, that when marginal revenue is positive, that means total revenue is increasing as price falls. That's the elastic range of this demand curve. When marginal revenue is 0, that's the unit elastic point, and when marginal revenue is negative, that's the inelastic range of this demand curve. Single price monopolies are not allocatively efficient, and they produce dead weight loss as a result. Let's see if we can calculate the surplus for this monopoly as well as the dead weight loss. The consumer surplus is found on that triangle. Base times height divided by 2 will give the answer. And here, plug in the numbers, it's $150 worth of consumer surplus. That quadrilateral here is the producer surplus because the monopoly is charging a higher price than the marginal cost there. So calculate the area there. It's the base times height divided by 2 for the triangle, and then base times height for the rectangle portion. Plug in the numbers, and that gives us $450 worth of producer surplus for this monopoly. The dead weight loss is a triangle that points to the allocatively efficient quantity of 40 units. Calculate the area of that triangle, base times height divided by 2, and that will give you the dead weight loss as a result of this monopoly underproducing. 10 times 10 times a half gives you $50 worth of dead weight loss. Now we're on to factor markets, and you already learned a little bit about this math back in Unit 3 when you learned the production function. The first new math you need to know for this unit is the marginal revenue product. That's the marginal product of a worker or other resource times the marginal revenue for that product. For many firms, the marginal revenue is the price. Let's try out the math with this table. Let's assume that the price and the marginal revenue of this product is $10. First thing we're going to do is find the marginal revenue product for those first 3 workers. Multiply the marginal product by the price of $10. And that gives us these marginal revenue products for those workers. Next, we're going to work backwards and find the marginal product when we are given the marginal revenue product for workers 4 and 5. Divide that marginal revenue product by the marginal revenue of $10, and that gives us these marginal products for the 4th and 5th workers. When a profit maximizing firm is deciding how many workers to hire, it will hire the number where the marginal revenue product of those workers equals the marginal resource or factor cost. That means they will hire where the MRP equals the MRC. Let's see if we can figure out how many workers this firm will hire if the marginal resource cost and the wage are $75. Well, that 4th worker has a marginal revenue product of $80 and a marginal resource cost of $75. That means hiring that worker will increase profit by $5, and this firm should hire that worker. But that 5th worker has a marginal revenue product of only $60. That means they're going to lose $15 if they hire that worker at $75 for the wage. And that means this firm is going to hire 4 workers because $80 is greater than $75 and $60 is less than $75. The next thing we're going to look at is the difference between the marginal resource cost and the supply of labor for a monopsony. Since a monopsony must increase the wage as it hires more workers, we're going to see a disconnect between those two. The total resource cost for a monopsony is the wage times the quantity of workers that a firm hires. The marginal resource cost is the change in that total resource cost divided by the change in quantity. Or essentially, it's the change in the total cost for hiring one more worker. Let's see if we can figure out the total resource cost for 2 workers for this monopsony and the marginal resource cost for the 3rd worker. For this firm, the total resource cost for 2 workers is $22. And the marginal resource cost for the 3rd worker is $14. The first 2 columns on that table, the quantity of labor hired and the wage, that is the firm's supply of labor. The marginal resource cost curve, on the other hand, is the quantity of labor versus the marginal resource cost. Those 2 columns get graphed out for your marginal resource cost curve. And as you can see, because of the fact that this firm must increase wages as it hires more workers, the marginal resource cost is going to be greater than the supply of labor for this firm. And that's why when you graph it out, that marginal resource cost is greater than the supply curve for a monopsony. They hire where that marginal resource cost equals the marginal revenue product, and they pay the wage that is down below at the supply curve. Now on to Unit 6, which is all about market failures. One of the market failures you need to learn about is externalities. Negative externalities occur when the marginal social cost is greater than the marginal private cost. That's going to lead a market to overproduce this product. On this graph here, the market quantity would be 20 units of output. The allocatively efficient or socially optimal quantity would be 10 units, and that's going to give us some deadweight loss as a result of this marginal social cost being higher than that marginal private cost. It's that triangle right there. You'll notice that the deadweight loss points to the allocatively efficient quantity. Can you calculate the area of deadweight loss? That's right. To calculate the area of a triangle, it's base times height times a half, and that gives us $50 worth of deadweight loss on this negative externality. In order to correct for this negative externality, the government could impose a per unit tax that is equal to the vertical distance between the marginal private cost and that marginal social cost. That will shift the supply curve upward to that vertical distance, getting us the 10 units of output. The amount of tax revenue the government will bring in as a result of that tax is found in that box right there. Calculate the area of it, and that's the tax revenue we will get. When there are spillover benefits to people who don't buy or sell a product, there are positive externalities. That's going to lead a free market to underproduce a product. We will have the marginal private benefit being less than the marginal social benefit. We see that here in this graph. 20 units of output is the market output, and the allocatively efficient output here is 30 units. That's where the marginal social benefit equals that marginal social cost. And since we are underproducing, we're going to have some deadweight loss, pointing to the allocatively efficient quantity. Calculate the area of that triangle of deadweight loss. It's base times height times a half, and that gives you $10 times $9 times a half, and that's $45 worth of deadweight loss as a result of this positive externality. And if the government were to offer a per unit subsidy to the consumers of this product, it would shift that demand curve until it merged with the marginal social benefit curve. That box right there is the amount of money the government would spend on this subsidy, bringing the market to the socially optimal output. Calculate the area of it with base times height, and that gives us 30 units times $9, and that gives us $270 that the government would spend subsidizing this product. Next up, we have types of taxes. Now, taxes are classified based on the percentage of people's income they make up. Progressive taxes take the higher income level people and charge them a higher percentage of their income for that tax. United States income taxes are an example of a progressive tax. Regressive taxes, on the other hand, charge a higher percentage of income for the poor. Sales taxes, for example, are a regressive tax. Proportional taxes, also called flat taxes, take the same percentage of income from all income levels. Let's take a look at this example. Let's say incomes of $10,000 pay $2,000 worth of tax in an economy, and incomes of $100,000 pay again $2,000 worth of tax. On the surface, it may look like a proportional tax since it is the same amount of money for both high and low incomes. But if you divide the tax by the income, you will see that the low income earners are paying 20% of their income for this tax, while people with a high income are paying just 2% of their money for this tax. That means this tax is regressive. The last bit of math you need to know on your AP Microeconomics exam is the Gini coefficient. The Gini coefficient comes from the Lorenz curve. The Lorenz curve shows us the distribution of income within an economy. The line of equality is that 45-degree angle line right there, and the green line is our line of actual income distribution. The further the income distribution is from that line of equality, the more unequal this income distribution is. The values on this graph can give us a Gini coefficient if we take the area of A and divide it by the area of A plus B. Now, I don't expect they would ever ask you to actually calculate that Gini coefficient, but you may be asked to interpret that Gini coefficient. And the lower that Gini coefficient is, the more equal the income distribution is within a society. And on the flip side, the higher the Gini coefficient, the less equal the income distribution in a society is. So here are 3 countries. Which of these countries has the most equal income distribution? That's right, it's country C. Whew, there you have it. That is all the math that you are likely to see on your AP Microeconomics exam. If you still need more help, head over to reviewecon.com where there's lots of games and activities to help you practice the skills that you need to know on that exam. And don't forget to like and subscribe and purchase the Total Review booklet from reviewecon.com. The link's below in the description. Take care. I'll see you guys next time.